Alright, this is page 2 of your review guide. We have a polynomial function in number 6, a rational function. It's a fraction. And they ask us, where does it have discontinuities at? And so let's factor the numerator. I'm going to use 4x for that one. 1 and 1, and negative, positive. And the denominator, difference of 2 squares, 2x minus 1, 2x plus 1. Actually, it didn't look like anything cancels out, so I don't get any holes in it. A hole is sometimes referred to as removable discontinuity. And if you look at it, I'd have to have a common factor to get a hole. I don't have any common factor. So I'm just going to have vertical asymptotes, and let's just remember what makes each factor equal 0 in the denominator. So this one's x equals 1/2, the other one would be x equals negative 1/2. So those are vertical asymptotes at positive 1/2 and negative 1/2. So that looks like, let's see, vertical asymptotes at plus or minus 1/2. Answer A. Number 7, h varies inversely with t. So h equals k over t. Then they give us some information. They tell us that h is 8 when t is 6. So this tells us k is equal to 48. So now we have the expression for h and t and how they relate to each other. 48 is the k value. The question they want us to answer is find t when h is 16. So we're going to let the h be 16, and we'll find out what t is. Multiply both sides by t. When we divide by 16, we get t is equal to 3. Problem number 8. It tells the volume of a cone, V, varies jointly to its height and its radius square, or the square of its radius. It says now that V is 18 pi when h is 6 and r is 3. And so 18 pi equals k times 6 times 9. That's 54. Actually, I'm going to divide out the 6 first. 3 pi equals 9k. And so k equals 3 pi divided by 9, or 1/3 pi. So now I know the equation for V as it relates to the height and the radius. Now they ask us a question. They say when V is 12 pi, so we plug in the 12 pi for V. And h is 4. They want us to figure out what r is. So to simplify this, I would first divide away the pi from both sides. I'm going to multiply by 3 on both sides to get rid of that fraction. I'll divide by 4, and then I'll square root it to get r is plus or minus 3, but r is a radius, and radiuses are always positive in measure. So r would be 3. Alright, let's jump on down to number 9. Problem 9, we have to simplify this expression. Notice it's not solved, there's no equal sign in it. So we've got x plus 3 over x plus 5 minus 4 over x minus 5 plus 3x minus 7 over x minus 5x plus 5. Notice we factor the denominator if it needs factoring. And now we can see if we're going to combine these, we have to have common denominators. So I'm going to take each one times a version of 1 so that all the denominators look the same. So the first one needs to be taken times x minus 5 over x minus 5. The second one needs to be taken times x plus 5 over x plus 5. And the third one already has the correct denominator. So now multiplying my numerator, just together I get x squared minus 2x minus 15. I just distribute. Okay, I just did a big FOIL problem there, if you will. Here I have to distribute a negative 4, so I get negative 4x minus 20 plus 3x minus 7. That's the third term, all over the common denominator, x minus 5x plus 5. So let's look for some like terms on the top, like here's an x squared. He doesn't have anybody like him. Here's a negative 2x, negative 4x, it's negative 6x plus 3. So negative 6 plus 3 is 3x's. And then finally all my constants. It's negative 35 minus 7, negative 42. All over, and if I peek over here at my denominators, they've remultiplied it together, so x squared minus 25. And that looks like answer D. Alright, moving on to number 10. Let's erase a little bit of this stuff so we have some room. Problem 10. This one is a solved problem, and since I have a fraction equal to a fraction, I'm just going to cross multiply. I get 3x plus 6 equals 4x minus 8. I'm going to add 8 to both sides. It's 14. I'm going to subtract this 3x to the right side. Gives me x. And I'm done. 11 now I cannot cross multiply in because it isn't just fraction equals fraction. So instead I'm going to use a method to get rid of all the denominators. So I've got 4x over factoring x minus 1, x plus 1, plus 4 times over x minus 1 rather, equals 2 over x plus 1. And looking at the denominators, to cancel each one out, I'm going to have to multiply everybody by the same thing. In this case, x minus 1, x plus 1. Okay, here they completely cancel, leave me with 4x. Here the x minus 1 cancels, leave me with 4x plus 4. I had to distribute that 4 to the x plus 1, and finally the x plus 1's cancel, leave me 2x minus 2. It's a linear equation. I don't have any x squareds in it, so I've combined my two 4x's. I'm going to subtract the 2x over to the other side. That's not 8x squared, that's just 8x. I'm going to subtract 4 to the other side, and x is negative 1. However, notice, negative 1 will cause that denominator to equal 0, so x cannot be negative 1, it's not in my domain, and so my answer would be there are no solutions to this equation. Okay, that's a fine detail that we have to be careful of, so no solutions. Let's do the same thing to number 12. Let's factor all of our denominators as we rewrite the problem. There we go. And now let's multiply everything times an x plus 2, an x minus 3, and an x plus 3. We're going to take that times everything. So let's put it by each numerator. Let's cancel before we multiply. So those cancel. 2x plus 4. 2 times x plus 2. X minus 3's cancel. X plus 2's cancel. 3 times x plus 3. That's a plus sign right there. And lastly, x plus 2 and x plus 3 cancel. 4x minus 12. So on the left I've got 5x plus 13 equals 4x minus 12. So x equals, subtracting 13, negative 25. And it looks like that doesn't make any of my denominators 0. So negative 25 is my solution.